Please share this video and the others that you are watching in my channel. Share them to your friends, your WhatsApp group. You just copy the link there, share, you go to share, copy the link, and then share to your friends, share to groups. That is the only way you can assist me, kwa sababu najua huwezi nitupea pesa, si ndio? Sasa unisaidie ku share these links, share the videos to your WhatsApp groups. Hivyo utakuwa umenisaidia. Longitudes and latitudes. So kitu ya kwanza tunafaa kujua ni the difference between a small circle and a great circle. Kwa hivyo ukishajua hiyo ndio inakuanga shida kwa watu wengi. So we want to know what is the difference between a great circle and a small circle. Once we identify that, everything is going to be clear. With me here, I have a crop. This crop has this circle, as you can see. There is this circle here. There is this circle at the middle, and there is another circle here at the bottom. I hope you are seeing it. This circle here at the bottom. There is this circle at the middle, and there is another one there. Wewe ukiangalia vizuri, hii circle iko hapa juu. Acha niweke hivi uone. Hii circle iko hapa. Na hii circle iko hapa hivi. Na haka kasako kako hapa. Usiangalie the bottom, hii ni ya kusimamia the base. I'm talking about this circle here and this one. And there is another one here. Sinatoshana? Hasitoshani. Kwa hivyo, this is the equator. This is the latitude where we have the equator. Here, the one that divides the globe into two. The lower hemisphere and the upper hemisphere. This is the equator. So, there is something I put here. There is the white lobe you are seeing here. This is the diameter of the earth. So if you look at this diameter and this diameter of the bottom here, as it was shown, this one is small. So the equator forms a great circle. The equator is the only latitude which forms a great circle. The other latitudes to the north and to the south, they are small circles. So the equator is 0 degrees. We have 1 degrees north, 2 degrees up to 90 degrees north. And then we have 1 degree south, 2 degrees south to 90 degrees south. So any latitude below 0 and any latitude above 0 degrees north, 0 above 0 north, that is 1 north, 2 north to 90 north. And any other latitude below the equator, which is 1 south, 1 degree south, 2 degrees south, 3 degrees to 90 degrees south, are all small circles. These lines that go across like this, we call them the latitudes. This line you are saying that, so we are saying that this is the equator, and this line that goes like this, we call them latitudes. So these lines are called latitudes. Any line that goes down like this, another one, this one itself, they are called longitudes. We have said that all longitudes are great circles. All of them are great circles. All longitudes are great circles. It is only the equator that is a great circle. The equator is the only great circle among the latitudes, because the equator is the latitude. So the green meridian, which is at 0 degrees, and the equator is our reference point. When we want to locate a point or a place on the globe, these are the lines we use. So, for example, point A is on 50 north, 50 degrees north, 30 degrees east. P is 50 degrees north, 50 degrees west. The first angle is the latitude. The second one is the longitude. Longitudes are measured from the green meridian. The green meridian is 0 degrees. From here to the west is 180 degrees, and it is west. From here to the east, it is 180 degrees. The equator is 0. We have this down 1, 2 degrees south, all of these are all latitudes, and this one are latitude to the north. The maximum latitude is 90, the maximum another down here, 90 degrees north, 90 degrees south. So let us locate this place on the graph, this point A and B. So to do that, draw a sketch. First, put the equator 0 degrees. Second, put the green meridian, which is 0 degrees. This is the Greenwich. The Greenwich meridian. After that, we have 50 north. 50 north is a latitude, so we start here. This is 9. This is equator, which is 0. So 50, this is 10, 20, 30, 50 will be somewhere here. So this one is 50 degrees north. And then 30 degrees east. This is the green meridian, which is 0. Greenwich meridian, 0. So we have 30 east. East is on the right side, this side. So east, 30 will be somewhere here. Right? So we draw this. This one is 30 degrees east. So it means point A is here. This is point A. Point B. Point B is on the same latitude 50 and 50 west. So west is the longitude. We come back to the latitude, the longitude, and then tunamesha kutoka hapo. Kama hii ni 0, so 50 itakuwa somewhere here. So 50. So hapa ndio 50. 50 west degrees. So we have quoted the 2 points. Kwa sababu hii point A and point B ina lie on the small circle, center yao inakuwa hapa. This is where their center is. That's where their center is. So let me draw a point along the great circle. So point A and B here, they are on a small circle. Small circle kwa nini? They are on latitude 50. All latitudes apart from the equator, they are small circles. Tunataka kuweka point A and B on this graph. We want to locate point B and B on this graph. The first thing you do, draw the equator. The equator we draw it because it is our reference point. 0 degrees north, 0 degrees south. It is our reference point. Second thing, draw the green meridian because it is our reference point to the west and to the east, 0 degrees. So we have this point A, which is 80 degrees north. So this is, remember, is the latitude. So the latitude we compare with the equator. So north, it is up the equator. So that is will be 40, 50 somewhere here. This one is 80 degrees north. And then 70 degrees east. 70 degrees east, this is the longitude. The longitude, so 70 somewhere here. We put it there. This one is 70 degrees east. Point B, so it means that point A is here. This is point A. Point B is 30 degrees south. So this one tells us it is below the equator. So this is the equator. If this is the equator 0, south begins here, downwards. So it means 30 degrees will be somewhere here. This is 30 degrees south, right? So, but they are on the same longitude, so they are on the same, this longitude 70, so it means this is point B. Because all longitudes are the great circles, it means that the angles subtended at the center of the earth will be where the equator and the green meridian meet. So their center will be here. Their center will be here. The angle subtended at the center is this angle. Any great circle, the center is at the green, where the Greenwich and the equator meet. For a small circle, it is not the case. The small circle, they meet up there. If there is another small circle here, there is another there, so their center is here and not anywhere else. But for this one, their center is here. That is now important. So distance along a great circle. We can calculate the distance along a great circle in kilometers and in nautical miles. But how do we calculate the distance? I want to use this. For example, the distance from A to B is the arc length of this point A and this one. How do we calculate the arc length? We learned that in Form 1, even Form 2. So arc length is given by theta over 360 to pi r, where r is the radius, pi we know the angle. Theta is the angle. Theta is the angle subtended at the center of the earth. So I'm going to show you how to get the difference, the angle difference. So this is how you calculate the distance along the great circle in kilometers. In nautical miles, you just get the theta times 60, and that is you are done. So this one will give us in nautical miles. Let us look at this example. The position of 2 points on the Earth's surface are A, 40 degrees south, 40 degrees west, and B is 60 degrees south, 45 degrees west. Calculate the distance between towns A and B along the great circle in kilometers and in nautical miles. Radius of the earth is 6370. So we go and do it. So let us now locate our point A and B on the globe. It is important that you sketch. So point A is 40 south, 40 degrees south. This is the equator. So 40 south will be somewhere here, right? Will be somewhere here. This is 40 degrees south, and then 45 degrees west. So this is the green meridian, so 45 west will be somewhere there. 45 west. So this one is 45 degrees west. So it means this point here is our point A. And then point B is 60 degrees south. 60. So this is 40, 60 will be somewhere there. This is 60 degrees south. But they are on the same longitude, 45, 45, this one. So it means the point is here, right? So this is point B. So the center of this is here. So it will form this as the center. So what we want to calculate the distance AB. And because it is along a great circle, the formula is theta is equal to 360. Theta over 360 2 pi r. R we have been given. So how do we get the theta? Theta is the angle difference. The angle of the latitude, the difference. They are on the same side, the south-south. So the angle difference is 60 degrees minus 40. and the answer is 20 degrees. That is the angle difference. So theta is 20. So you put 20 over 360 times 2 times 22 over 7 times the radius 6370, and that one gives us the length AB, the arc length, which is 22.4 kilometers. Now this is in kilometers. We can now calculate in nautical miles. The formula for calculating nautical miles, you can convert this one or just go direct and say distance in nautical miles is given by theta times 60. So theta we have it is 20 times 60, and that one gives us 1200 nautical miles, like that. You can as well convert 1 nautical mile is equal to 1.853 kilometers. You can as well ask what will be these kilometers. 22 to 4.44. How many nautical? So you can as well convert like this. That is 22 to. So the answer is 1.1 nautical miles, which is the same as this. Distance along a small circle. All latitudes except the equator are a small circle. So this one here is a small circle, but the equator is not a small circle, it's a great circle. So I want to ask, we know the diameter of, and we know the diameter of the, and we know the radius of this one. The radius of the great circle is R. That one we know, and we know it is 6370 kilometers. But now we don't have the radius, and the radius of the small circle cannot be the same, because the radius here cannot be the same as the radius here, right? So we want, how do we get the radius here? So there must be an angle subtended here, because these lines are parallel. This line and this line are parallel latitudes. If they are parallel and this is a transversal, then it means this angle here is this angle here, because they are alternate angles. Very important to know. This angle here, the latitude angle, is the angle subtended this one, because they are alternate. If the same way I draw this one here, the angle here is the angle here. You should know that. It's very important. It is going to help us. And then, so the radius of a small circle, radius of a small circle is given by alpha over 360 2 pi r cos theta. Now I want to define what pi is and what this one is. Because this is a small circle, there will be a latitude there. So that latitude angle is the theta. You can see the angle here, theta. So where alpha is the angle difference, and theta is equal to the angle of the latitude angle. Theta is the latitude angle, and the alpha is the angle difference between the 2 points. So our formula is here, and that is what we are going to utilize. If this one, it will give us in kilometers. If I want the distance in nautical miles, distance in a nautical mile along a small circle is given by 60 times alpha times cos theta. Alpha remains the same, the angle difference. Theta remains the latitude angle. So this one will give me distance in nautical miles along where? A small circle. Along a small circle. So let us do an example. So find the distance between A and B, which has been given these coordinates. So let us locate these points on the globe. It is important you sketch. Let us sketch. A is 50 south. south, this is the latitude, so it is below the equator. So 50 south could be here. You write 50 degrees south, and then 35 degrees east. This is the longitude. So the longitude we count from the prime meridian. So 35 will be somewhere here, and this one is 35 degrees east. And then point B is on the same latitude, 50 south, the same latitude, but the different longitude, which is 80 west. So this is the 0 to the west is west, so we are going to the west, which is west, and this one is 80 degrees west. Therefore, we have our point B here. So because this one is a small circle, if it is a small circle, we will draw, the circle will be like this. So where is the center? The center is here. This is point A is here, P is here. So this is our center, and the angle difference is this theta here. That one is our. So let us get the angle difference. So from west 80 to 0, that is 80, plus from 0 to 35 east plus 35. So the angle difference theta is going to be 115 degrees. So we have gotten, this is the angle difference. Angle difference. And the angle difference is what we call alpha. Right? The angle difference for a small circle is the alpha. Nimejuaje ati hii ni small circle? Kwa sababu inafita kwa 50 south. 50 is a small circle. 50 south, 10 south, 20 south is a small circle. Hivyo ndio unajua kwamba hii ni small circle. Kwa hivyo now we know that the formula is that alpha over 360 2 pi r cos theta. Na theta tumesema ni nini? Ni latitude angle. The latitude angle here is 50. Unaona yenye inafanana. That is the latitude angle. So now we have 115 over 360 times 2 times 22 over 7 times r. R is 360, 370. Always imepeanwa hivyo. Times cos latitude. The latitude here is, you can see it is 50. So this one gives us the distance along AB in kilometers, which is 822 kilometers. So next one is to calculate the distance in nautical miles. So this is a distance in and then in nautical miles, we can simply use the formula 60 alpha cos theta. 60 is a constant times alpha. Our alpha is 115 times this one is cos 50, and this one will give us 435 nautical miles. 35 nautical miles. So that's how you calculate the distance along a small circle and a great circle. Longitudes and time. The Earth rotates on its axis at an angle of 360. One revolution ikisunguka mara moja ina cover 360 degrees, and this one takes 24 hours a day. It takes 24 hours. So let us find what will be 1 hour. What will be the angle 1 hour? So that one will be 360 times 1 divided by 24. So inamaanisha in 1 hour the Earth rotates 15 degrees. So we know that 1 hour is equal to 60 minutes. So if 60 minutes is equal to 15 degrees, what will it be 1 degree? What will be the time for 1 degree? So it is 1 times 60 divided by 15, and this one gives us 4 minutes. So for every change of 1 degree along the longitudes, there is a change in time of 4 minutes. Every time 1 degree changes from 1 to 2 degrees, there is a change in time either to the west or to the east. So this is the green meridian and this is 0. To the east, this one is east and the west. The time to the west is behind the time on the east. The time on the east is always ahead. The time to the east is ahead. The time to the west is behind. So we look at that. So it means that for every 1 degree change in a longitude, there is a corresponding change in time of 4 minutes. Very important. So we are going to use this relationship to calculate the time at the given points or at given places. For example, find the local time in Nairobi, 1 degree south, 37 east, when the local time in Mandera is 4 degrees north, 42 east. You see both of them, they are in the east. So that you should make. So, and remember, for time, we are considering only the longitudes. We don't care about the latitude. We are interested in the longitudes because we have said the change in the latitude, in the longitude, not latitude. The change is in the longitude and not the latitude. So we don't care about the latitude. We want to change the angle change in the latitude. So the angle change, the angle difference in longitude is, as you can see, there east, so it is 42 minus 37, and this one gives us 5 degrees. But we know that 1 degree is equal to 4 minutes. So now we want to find out the difference in time. You will ask 5 degrees will be what? This one will give us 20 minutes. But as you can see, Nairobi is 37 east, and then Mandera is 42 east, meaning that Mandera is ahead of Nairobi. So for us to get the time in Nairobi, which is behind Mandera, the time, we are going to subtract the time, because Nairobi is behind 37. As you can see, it is 37. It is on the west of Mandera. That's the most important thing. Although they are in the east, both of them, but Nairobi is on the east of Mandera. So if in Mandera it is 3 p.m., then Nairobi will be 20 minutes behind. So Nairobi will be 2:40 p.m. If we were getting ahead of Mandera, we were to add the time. This 20 minutes, we add that this one will repeat it 20 if it is in ahead of Mandera or to the east of Mandera. If, for example, it was 50 degrees east. If the local time in town P, 60 degrees north, 5 east northeast, 50 east, is 2:30 p.m. Find the local time of town Q, 60 degrees north, 120 west. So the angle difference along the longitudes is 120. Remember, we have 120 west and then 50 east. So it is from 120 east to the green meridian, which is 0, and then from 0 to 50. So that's why we are going to add 120 plus 50. So the angle difference is 170 degrees. That is the angle difference. Then we shall ask, 1 degree is equal to 4 minutes. What about 170 degrees? So it will be 170 times 4 divided by 1, and this one will give us 680 minutes. So we convert this minutes to hours. You will find it is 11 hours, 20 minutes. When you convert it, you will have 11 hours 20 minutes. But we are looking for the time to the west. The question asked time, a local time in town Q, which is in the west, 12 west. From east to the west, we subtract the time. So the time there is 2:30 p.m. Now we are supposed to subtract 11:20 minutes. So change this time into 24 hours. So that one will be 14:30 hours, right? And then we will subtract 20. This one will be 10. 4 minus this one will be 3. So remember, this was PM. So this one most probably is AM. So the answer is tisa asubuhi, 3:10 AM, and that is the time in point Q. In place Q, the time is 3:10. You subtract if the time asked is to the west. We know that speed is measured in knots or in kilometers per hour. So speed measured in kilometers, it is given in kilometers per hour. So something new we are going to learn is about the knots. We know that speed is equal to distance divided by time. So this one, if the distance is in kilometers divided by time, it will give us kilometers per hour. So speed in knots is given the distance in nautical miles divided by time. So to get the distance in knots, you must have distance in nautical miles and then divided by time to get the answer in knots. That is the only thing you need to know. So for us to get the speed, first we must calculate the distance. We have learned how to calculate the distance. So it is your duty to identify whether the distance you are being asked is along the great circle or a small circle. And then once you get the distance, you divide by the time you are given, you get the speed. An object moves from 30 degrees north, 0 degrees to 30 degrees north, 45 degrees east in 3 hours. Calculate the speed of the object in kilometers per hour and B in knots. So like I have said, first we must get the distance and then we have time, we will get the speed as simple as that. So first we want to know, is this a small circle or a great circle? How do you know? This one is a small circle because the latitude is 30. So 30 is a small circle because we said all latitudes are small circles except the equator, which is 0 degrees. So let us get the angle difference. So the angle difference will be 45, 0, that one is 45 degrees. That is the angle difference, and this one is the alpha. How do we get the distance in kilometers along a small circle? We know the formula, it is alpha over 362 pi r cos theta. Our alpha is the angle difference, so we have 45 over 360 times 2 times 22 over 7 times 6370 cos latitude. The latitude is 30, cos 30. This one will give us the distance as 34.46 kilometers. Now we have the speed, the distance, but we know speed is equal to distance over time. Our speed is our distance is 334.46 and our time is 3 hours. So we are going to have now the speed, and our speed is, we divide by time, which will give us 144.82 kilometers per hour, and this one is the speed. So you see, you need to calculate the distance first. Part B, we are supposed to calculate in knots. For you to calculate the speed in knots, we must have distance in nautical miles. We must have distance in nautical miles. But we know distance in nautical miles is given by 60 alpha cos theta. We have 60, which is 60 is a constant, times alpha, which is 45, times cos 30. And this one gives us 2338.27 nautical miles. So speed in knots is equal to distance in nautical miles divided by time, and that one is 2338.27. we divide by 3 hours, and this one will give us 779.42 knots. Now next we will look at the longitudes and latitudes applications. Now, how do we apply now the knowledge we have gotten to calculate to solve some problems given?